So for improper integrals, you also might want to look at a comparison test. So if f of x and g of x are both continuous on the closed interval from a to infinity, and f of x is between 0 and g of x for all x bigger than or equal to a, if the integral from a to infinity of g of x dx converges, then the integral from a to infinity of f of x dx will also converge. So if g of x is a bigger function than f of x, so if g of x is greater than or equal to f of x, so to look at a sketch, you got g of x, which is greater than the function f of x from a to infinity, and you know that g of x will converge to some number, then f of x will also converge to some other number. Second scenario is that if the integral from a to infinity of f of x dx diverges, then the integral from a to infinity of g of x dx will also diverge. So if you know that f of x is smaller than or equal to the g of x function, so you have f of x is graphed smaller than or equal to all the values of g of x from a to infinity, and you know that f of x will diverge, so the values of f of x will go to infinity, then g of x will also diverge since g of x is going to be bigger than where f of x is. So the first example, we're going to look at the integral from 1 to infinity of dx over x squared plus 3. And since 1 over x squared is going to be bigger than or equal to the function 1 over x squared plus 3, which is also bigger than 0, and if we look at the integral from 1 to infinity of 1 over x squared dx, which will look at the limit as a approaches infinity of the integral from 1 to a of 1 over x squared dx, which is the limit as a approaches infinity, anti-deriving 1 over x squared becomes negative x to the negative 1 from 1 to a, which is the limit as a approaches infinity, following the fundamental theorem of calculus of negative 1 over a plus 1, which is equal to the value of 1. So the integral from 1 to infinity of 1 over x squared dx converges. And since that was greater than or equal to 1 over x squared, then we can say the integral from 1 to infinity of 1 over x squared plus 3 dx will also converge. Next example, we're going to look at the integral from 1 to infinity of 2x plus 1 over 1 plus x quantity squared. The function 2x plus 1 over x plus 1 quantity squared is bigger than or equal to just looking at 2x over just x squared. And reducing that, that would just make 2 over x. So we can look at then the fact that the 2 over x is less than or equal to 2x plus 1 over x plus 1 quantity squared, which is also bigger than or equal to 0. So we can look at the integral from 1 to infinity of 2 over x dx, which is the limit as a approaches infinity of the integral from 1 to a of 2 over x dx. And anti-deriving, we'll get the limit as a approaches infinity of 2, the natural log of the absolute value of x, from 1 to a. And following the fundamental theorem of calculus, we'll get the limit as a approaches infinity of 2 natural log of a minus 2 natural log of 1. And replacing in the value of a for infinity, we get the value of infinity, which means that that integral diverges. So therefore, the integral from 1 to infinity of our original function will also diverge.